So I think pretty much a lot of what I've written just appears on these slides, so we'll go through them again, and then we're going to do a practice problem. Okay? Molecules that form a redox couple can be used to generate current or charge flow in an electrical circuit. This is just a fact that I told you. My apologies for that. Our goal was to relate deltaE to deltaG. These were the definitions that I gave for, again, I just want you to be comfortable if you see the words potential difference, voltage, like you know what term you're calculating. Okay? And so then we saw this example here, right? So we had our very first example that we looked at was oxidation of zinc and the reduction of copper. So if this setup here, as written, the oxidation of zinc and reducing copper is spontaneous, which again, like I said, I either told you or we got that information off our standard electrode potential chart, then this setup is true. The free energy of the solid copper is less than the free energy of the copper ion in its solution. The difference between these two would be less than 0, and this scenario is spontaneous. And the reverse situation, so the one where we said, oh, what happens if we put zinc, if we put a copper bar into a zinc solution, does zinc just start depositing on the copper? And we said, no, that would be non-spontaneous. So the reverse reaction is a non-spontaneous reaction. This is what I tried to draw for you. So if you recall from Physics 240 and 41, which should have been electromagnetism, then a particle with charge Q in an electric field fears this force equal to Q times the strength of the field. Work done. And again, work is just given to change in internal energy now because we don't have a heat component coming into play. Work is the force applied over some displacement. This was our infinitesimal displacement. For a fixed unit charge Q plus 1, this term here is our difference in potential in our field. And so this whole term, we can then just have difference in internal energy is equal to Q, our charge now, times our electric potential difference. And this was sort of potential energy, or the electric potential energy of moving the charge in the field is equivalent to sort of the change in potential or gravitational potential energy if you think of sort of a mass moving. Here are sort of our stock units, our standard units to orient yourself to. Standard unit for electric potential difference is the volt, capital V. Standard unit of charge is Coulomb C. If a charge of C moves through a potential difference of 1 volt, the work done is 1 joule. And the charge on the electron, I think all of this is given to you on your equation sheet. If not, I'll double check, but this whole relationship should be there. Okay. The charge on the electron, and then also Faraday's constant.